Hello everyone again and welcome to Python Tips. So today we'll be looking on how we can load data and explore that data in using Pandas. We already saw Pandas yesterday on how to use it. We start by importing Pandas and then we alias it as a PD. Now, loading data, we can use different ways. CSV simply means comma separated values. You can as well read um, Excel files, you can read text files. Let's say if I run this and then I want to get insert another cell below and I just do pd.read. If I do pd.read and do the tab key, we are going to see the different kind of things we can do with these pandas. We can read CSV files, we can read Excel files. Yeah, we can read different things. We can read JSON files, HTML files, and whatever file that we are working with, we can use Pandas to load that data from wherever we download it or the source where the data is coming from. So today I want us to download a data set is used a lot in machine learning called the breast cancer data set, where it's a data frame where we have breast cancer categorized as benign as well as malignant. Now, for you to do that, I will first of all take this. Let's see how we can download that data. You can just go to Google, type UCI machine learning repository. So it will open this. You will see different data set. We are going to use this a lot to get data set on for various demonstrations. Whether it's in building machine learning models, this is where we mostly get our data. You can also get data from Kaggle, which is another website where you can get data to test with different experiments and all the like. Now the data set we are going to be using is this breast cancer Wisconsin data set. You can click on it. You will find a description of the data and how you can download the data set. You see here we have the download option. If you click here on download, it's going to totally download the data set for you. It shows the description of the various columns that we have in that data set, as well as the number of baseline models that have been used. They have used XGBoost, support vector machine, neural network to carry out various experiments on this data. Now, as I did mention, you read. So this data set doesn't have so the columns. They only give the column descriptions. So here you can also just go here and get to the website, click that website and just take URL, and then you can download this data set directly. Because this data set originally doesn't have columns on it, that's why they only get the column names. So if you want to get the column names included in this data set, since the header, you don't know the header of this, you can just do df uh, pd.read underscore csv because it's a comma separated file. You pass that URL, the link to that data set. Header is equals to none, and then names will be equals to what? The column names that we have here. So that is how to read in a data set and then pass in those columns if it doesn't have columns. Some of this data set will have columns, but some will not. Now, if I read this data set, if I run this, the data set will be downloaded directly. And then now, if I want to see the first, we already saw how to explore maybe getting the first 5 rows in that data. If you just do df.head, it will give you the first 5 rows of the data. So that's why here you see first 5, we have different columns. Now let's take, for example, if I want to, let me insert another column here, insert below. If I want to do print uh, uh, in bracket df, I want to get the column names dot columns, I can press the tab key, it will come. And then I can, if I do print, I will have all the column names that we have there. That is how to get the different column names in the data set. Now, we can also do basic information about each of those columns, whether it is an int, whether it's object. We see here that the diagnosis is actually showing that it's an object because as I did mention, the diagnoses here are what? Malignant and benign. As we move on to machine learning, we will see how this becomes a binary class problem where we can give benign 1 and then malignant 0. And then we can run a binary classifier. We will see all of this as we move along. Now, if I want to check missing values, one good way, which is a good practice, especially when you are doing exploratory data analysis, using Pandas or wherever you are building machine learning models, it's always good to check missing values for the various columns. So you can just do df dot is new, and then you pass sum. So this sum here, it gives it the opportunity. If they are missing value for each of these columns, it is going to give us the sum this other way. So we can see for ID diagnosis, all of them are showing 000, meaning that they are not missing values. Another thing we can do is descriptive statistics for each of those columns. And remember, I mentioned yesterday that descriptive statistics will only look at the numeric columns, where it will give you the count, it will give you the mean, the standard deviation, the minimum, the first quartile, the median, which is the second quartile, and then the third quartile, which is the 75th percentile, and then the maximum value for each of those numeric columns. That is how we do this a lot to check which are the minimum maximum values in each column, so that if there is a lot of discrepancy as we move into machine learning, we will see how to normalize that data, especially if we are using distance-based machine learning models, so that the data is not that skewed towards certain distributions. Now, the diagnostic column we will see as we move ahead as the target variable, or whereas as we move along, that is, we call that the target variable, because if we are going to be a machine learning model, we will be predicting if that breast cancer is benign or malignant. So we do this a lot. So we do a count in Pandas data frames. You can just do df, you pass in that column name in as far as you know is categorical. You do value dot underscore count. It will give you the count for each of those categories. B here stands for benign, and M here stands for what? Malignant. So here we do this a lot to see the distribution of that data set. Is it right skewed? Do we have a lot of discrepancy in between these categories, so that we will see which kind of machine learning model we can use. Should we turn this problem to an abnormality detection problem? We are going to see all of this as we move along. Also, we can visualize this. As I did mention, you'll notice here that I imported matplotlib. We are going to see this in the next lessons, how we can do most of this visualization. A better way, instead of doing these counts as we did here, is just to plot a bar chart that is going to show you the distribution of what benign and what malignant. That is a good way, looking at the distribution. We will also see how we can plot this kind of distribution and put the count for each of these diagnosis type, whether it is for different categories. Guys, keep following for more. This is it for this lesson today. You can try to download this data set and do more of this practice. I will also be putting the link to this data set on the comment section. Thank you so much, guys, and see you next time.